While we're at it, let's do one problem with the compound interest from this section. I'm not going to go through the elaborate explanation of how compound interest works as recursion. I do suggest that you take a look at pages 298 to 300 where they do two examples and walk through this. When I'm in class, what we usually do is we do something like this, and I like to do it with an Excel spreadsheet and show doing a recursive formula in Excel to show how compound interest works. And it's always fun to take some real numbers from the day that students provide and show that with even a limited amount of deposits that you do every month, it is quite possible to become a millionaire by the time you're able to retire when you're 60 or 65. Compound interest is really interesting, and I thought there's some interesting quotes that Einstein made about it, how I thought this was one of the most fascinating things in all of mathematics. If you haven't worked with interest for a long time, you might want to remember the formula for simple interest. I is equal to PRT. The interest is equal to the principal times the rate times the time. Now your text has always been trying to divide the recursive formulas into section 5-6 and then looking at how to find the recurrence relations by iteration in section 5-7. I've been trying to combine some of these like we did with the Tower of Hanoi problems. Let's take a look at 37 though that's in your text. Again, what they've tried to do is they tried to make it some easy numbers. If you haven't done so, stop the video now, read number 37 in your text, because I haven't written everything here. The key parts of this is that you're working with 4% annual interest, and it says it's compounded quarterly, so that means it's happening every 3 months or 4 times a year. The first part of this is asking us to come up with a recursive formula for this. Well, the recursive formula says that we're going to take this 4% annual interest that's compounded monthly. It's compounded, whoops, it's not compounded monthly. It's compounded quarterly in the problem. They gave us easy numbers. So we're going to take 4%, divide it by 4, and basically we're getting 1% every quarter. So we're taking the 4%, percent remember means per 100, so we're taking this, we're dividing it by 4, and getting that we're getting 1% every quarter. So that's going to happen 4 times a year. If we were doing simple interest with this, the amount of interest we would get on, say, $1,000 would be 4% of that. Well, if we take the principal of, say, $1,000 and we multiplied it times 0.04, let's do it that way, for 1 year, well, 0.04, what's that going to be? If we did 0.01, that would move it 2 decimal places. That would be $10. It's 4. So it's $40, right? Now, let's take a look at doing this with compounding it quarterly. I'm taking the 1% every quarter, multiplying it times how much money we have, and then adding it to how much we had before. Well, every one of these things works the same way. Since my coefficient here is 1, and this is the 0.01, I can add these together and get the 1.01 times how much I had before. That's our general recursive formula for this. Part B says, suppose you start with $5,000. What we're doing is we're going to take the 1.01, multiply it times how much we had before, and when we multiply 1.01 times the 5,000, that's going to show us how much we have after 1 quarter. So let's see. That'd be 5,000. 1% of this would be. So what this is saying is at the end of 1 quarter, I would have $5,000 from my principal plus $50 interest for a total of $5,500. Well, the thing that makes this interesting, if you pardon the expression, is that the next time around you are getting interest on your interest. Well, if you do this recursively for 4 times, well, if you had just done it with simple interest, you'd be seeing that you'd be getting $50 every month, so you'd be getting $5,200. But since we're doing this recursively, we're doing interest on the interest, getting compound interest, it works out that we get an extra $3.02 at the end of that first year. Now, if you go on to chapter 5.7 and you start looking at this, you can see that it's easy to make an explicit formula for this, because every time we do this, we're multiplying by another factor of 1.04. So after 1 year, it'll have been 4 quarters, so it's 1.04 to the 4th power times the initial amount. So an easy way of getting to this number is to take 1.04 to the 4th times 5,000, and that gives us the 5,203.02 without having to go through all the recursion. Your text also has us take a look at finding the annual rate of return, the annual percentage rate here. And we do that by taking this amount, subtracting the initial amount, the initial principal, dividing by the 5,000 and getting the percentage. Again, if you think about the explicit formula, if I take the 1.01 and raise that to the 4th power, I get this number. And if I subtract 1 from that, you can see what I am getting is I apologize, I wrote that number wrong. That's 1.040601 if you put that in the calculator. You see, if I subtract 1 from this, I am getting the APR for this. In other words, if I put that in percent, it's 4.0604. Yeah, that's the APR. So I kind of like to combine those. I actually like the problems for the compound interest that are in section 5.7, so we'll take a look at another one there.